Okay, so we're on page 9. Okay, page 9. So we're going to go ahead and just do this problem together, and we'll kind of look at these. This is what you're looking at in 2.2 is how to do graphs and how to do transformations. Okay, so what your goal on this is to be able to do this. You don't need a calculator to do this. You can check with a calculator though. So the first thing you want to do is, if I say what's the elementary function on this, do you know what I'm asking? What am I asking? Y equals x squared, right, good. Okay, it's the simple one. You see a square there, so you have y equals x squared, okay? Now let's see if we remember this. This is what you're trying to learn. Okay, what does the plus 2 do? That's inside squaring. If it's inside squaring, we said left, right. So what does that do? That goes left, okay? And we're going to put these in order. So the first thing you want to write down is we're going to go left 2, okay, like that. Okay, the second thing you do, and you have to do this by order of operations, okay, and you got to think of it this way, is if you were to work, if you knew x, say x is 0, you would do inside parentheses number 1, then you would multiply, then you would subtract. That's following order of operations. What does the negative 1/2 do you know? It does reflect because there's a negative. What's the 1/2 do? It multiplies y values by half. So if you take all your y values and multiply them by half, they get smaller. As they get smaller, they shrink. Okay? I like you usually just write this like this because you'll understand it better. Write this down. We're going to multiply y by negative 1/2. Okay? And that will reflect and shrink it, and that's what we're going to see. And then what does the minus 1 do? Down 1, good. Okay, so you got to know those, what's going on each one of those things. Okay, that's going down 1. Okay, so here's what you want to do then. Does anybody need a 1.1? You need one? Okay, so you can get this taken care of? Okay, come on up and get one. Okay, all right? Okay, so here's what you're going to do. We're going to go ahead and we're going to make a table for y equals x squared. Okay, so y equals x squared, we're going to use -2, -1, 0, 1, 2. Okay, you got to graph the elementary function first, then we're going to transform it. Okay, all right, just do this in your head. Do it real quick. If you square -2, you get 4. Square -1, you get 1. Square 0, you get 0, and so forth. Okay, that like that. The elementary function, it's helpful if you just know it, but if you don't, you can figure it out. Okay. So what I'll have you do then is just graph these 5 points on the graph I gave you. So you got -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4, and then just do like a dashed line. That's not the final graph, but that's what we're transforming. That's y equals x squared. Okay. Everybody with me okay so far? Yeah? Tell me. Okay, all right. So what we're going to do, this is just the way I teach it. You can bypass doing this table of transformations. I'd like you to know how to do this on a test and everything because this is the safest way for students to learn how to do this. So what I want you to do down on this table here is we're going to make some columns. I've already given you the points we have in our table. Those are the points we're going to transform. So the first thing we're going to do is we're going to go left 2. We're going to do that. And then make another column. Then what we're going to do is multiply y by -1/2. And then finally what we're going to do is we're going to go down 1. So you have to know that order that you do stuff in. You got to study that. And the thing is, left, right is first. Anytime you have like a stretch or shrink or reflect, that's second. And the last thing is up and down. Okay? So watch how I do this very carefully. All right. How do you make all these points go left 2? What changes, x or y? X, okay? X changes, not y. Okay, so just leave these y values the way they are in step 1. Okay, just bring those down like that. And then what you want to do in your head is you just want to take all of these x values and make them go to the left 2. Okay, just do it in your head. So where does this go? Left 2. -2, where does it go? -4, where does that go? -3. and so forth, right? Okay, so just in your head, you're moving all of these numbers right now to the left too. So that'll be -4, -3, -2, -1, 0. Everybody with me there? Okay, so we're not going to plot those points yet, but that'll take care of the left too. All right. Now, what we're going to do next is we're going to multiply the y values by -1/2. So all these numbers I'm highlighting in blue are going to get multiplied by -1/2. So the x values, you don't do anything with them. Just bring these x values down because we're done with that. All right, then what we're going to do is just take half of all these numbers, okay? And you can do all this in your head. What's half of 4? It's 2, but then you're multiplying by -1/2, so that becomes -2. Okay, if you need to write down that you're doing 4 times -1/2, which is -4/2, then you can do that. Okay, so that takes care of that. Okay, what would the next one be? If you take 1 times -1/2, what do you get? -1/2. How about 0 times -1/2? Still 0, right? How about 1 times -1/2? 1/2. Everybody with me? And then 4 times -1/2, we already figured that out. That was -2. So I took -1/2 of the y value. All right, so everybody following what I'm doing? Okay. Okay, all right. Now what we're going to do is we're going to do down 4 or down 1. So that means the x values, we already got the x values. Just write them down. Okay, and now what we're going to do is you just do this in your head. You take all of these y values, and all those y values just go down 1. They get smaller by 1. Okay, so where does the -2 do if it goes down 1? Where does it end up? -3. How about -1/2 down 1? -1.5. Okay, you can even put -1.5 if you want to. How about 0 down 1? -1. -1/2 down 1. -1.5. -2 down 1. -3. Okay, so see what I did is I took these basic points that are in the basic parabola and I shifted them left 2, multiplied y by -1/2 and down 1. Okay, do you guys follow that? It's arithmetic. And you got to know the order we do that in. Now, what I want you to do next is you want to go ahead and these points right here, go ahead and go to your graph and just plot those points and then we'll have what our graph looks like. Okay, so go ahead and take these points and plot them and then we're done. Okay, so we would have -4, -3, -3, -1.5, -2, -1, -1, -1.5, 0, -3, so it went like that. Okay, now here's what I want to see if you understand or not. If you look at the red graph and the green graph, does it look like this point moved left 2? Yeah. Does it look like it moved down 1? Yeah. Does the graph look like it's been shrunk this way? Aren't they kind of like a different, I mean, they're the same shape, but imagine all those y values becoming half, so that thing gets shrunk. Does that make sense? Okay, so it's all there, it's just arithmetic. When you get right down to it, we're doing arithmetic on these problems, so that would be the idea, okay? So is there any question about that? Okay, thumbs up, thumbs down, tell me. Tell me something, okay?
Can you scroll back up just 1 second?
Yeah. Yeah, what do you need me to do?
I'm just trying to see where it says the elementary function is.
Oh yeah, the elementary function is just y equals x squared. Okay, and that's because you have something squared. If you had a square root, the elementary function would be y equals x, square root of x. So if you look back in the notes, I think there's 7 elementary functions. They're in there. Okay, so that's what we mean. Okay. All right, now we're going to learn something a little different. We're going to learn what we call a piecewise function. These are really a big deal in business a lot. Most of your functions are piecewise functions. That's the way most of them work when you're doing a lot of things. So piecewise functions are you just have 2 or 3 functions that are defined on different intervals. So what I'm going to do is I'm going to show you how to graph these and how to put these together on the next page. Okay, so let's go to the next page and I'll show you how to put these together. I'm also going to show you how to do it with the calculator and without the calculator. So if you've got your calculator, you'll want to do this along with me. Okay, so the first thing we're going to do is the first piece is 2 minus 2x. Do you know what the graph of that looks like? Can you tell me that? What kind of function is 2 minus 2x? Do you know? It's linear, so it's a line, right? Okay, so what we're going to do is we're going to make a table. This is the way I usually teach this. We're going to start with 2, but since that says less than, that means it's open. It's an open bubble. If it's less than or equal to, then it's closed, meaning it's an included point. So you got to put that little indicator to yourself there. Now you're just going to pick numbers smaller than 2, because that says x less than 2. Let's go 1 and 0, and that's good enough. Hey, it's a line. It only takes 2 points to make a line. Okay, so what we're going to do is plug in here. So we have 2 minus 2 times 2. What I'm doing is taking the x value I'm choosing, and I plug it in. Okay, do that arithmetic in your head. That's 2 minus 4, so that is negative 2. So you have a point 2, negative 2. All right, now plug the 1 in. So you're going to have 2 minus 2 times 1. That's 2 minus 2. That's 0. Okay, like that. Plug the 0 in. So then you would have 2 minus 2 times 0. So that is 2 minus 0, so that's 2. So what I'm doing is I'm starting with 2 because that's the end point of that. But since it's less than, that's going to graph as a bubble. Okay? And then basically I'm just picking numbers to plug into that equation. I'm doing arithmetic. Everybody follow that I'm doing arithmetic. Okay? Now, what you want to do is you want to go ahead and plot these points. So go ahead now and just plot these points. So 2, negative 2, you're going to go to the right 2, down 2, and you're going to put an open dot there. Okay? Then do 1, 0, put a solid dot there. And 0, 2, put a solid dot. And this is a line, so whenever you're to the left of 2, then that's your line. Now here's what students do all the time. Can anybody tell me why the line doesn't go that way? I see students do it all the time. How come? Exactly, because it said x is less than 2, right? So when x is less than 2, then you have your graph, say. Okay, so don't go beyond that. Does everybody understand what I'm saying there? Okay, all right. Now what we do is we just do the second graph. We do this the same way. What kind of graph is y equals x minus 2? That's linear. It's a line again. Okay, so what we do is what we're going to do is we're going to start with 2, and then what you want to do is put a solid dot there. The reason it's solid is because it says greater than or equal to. Equal to includes that point. Okay, then we're just going to pick a couple of numbers bigger than 2, like pick 3, pick 4. So start with 2 and then just pick a couple of numbers that are bigger. Okay, whatever you want. Then we plug those numbers in here, so we would have 2 minus 2 is 0. We would have 3 minus 2 is 1. And then 4 minus 2 would be 2 like that. Does everybody follow what I'm doing? Arithmetic, okay, plot points. Okay, so now what you want to do, go to your graph, plot the point 2, 0. So you're going to go over 2, put a solid dot there at the point 2, 0. Plot 3, 1, go over 3, up 1, and then plot 4, 2. Go over 4, up 2, and then go to the right like that. So that's what your graph looks like, is like this. Now, let me see if you guys know this or not. Why do I not take this blue line and go all the way that way? I see students do it all the time. Because it's greater than or equal to 2. When x is greater than 2, that's what your graph looks like. Does everybody understand that? I see people do that all the time, and that's a function. So that would be the way the answer goes. Now get your calculator out. It's also very nice to know how to do this on a calculator. So let me get this kind of set up here. Come on. There we go. Okay. So I'll show you how to do this. The first thing that you got to do is on your calculator, before we put anything in, you need to locate the math button. And above the math button, it should say test. Okay, that's important. So just do this to start with. If you go second, then math, then you'll see all these symbols. So you have to know where all these greater than and less than symbols are. So make a note to yourself if you need to. That's under math test. Okay, so what we're going to do is we're going to graph like this. Press your y equals button. If you have any graphs in there, clear them out. So what you do is you do this like this, okay? So try to follow. If I'm going too fast, just let me know. You're going to graph 2 minus 2x, but you want to put that in parentheses. Go 2 minus 2x. You got your x key, and then close parentheses, like that, okay? All right? Then put a division symbol, okay? And that division symbol is going to separate the x less than 2. So you got to go like that. Now put a left parenthesis, and then we're going to put in the x less than 2. So press your x button. Now you got to find less than. Where did I say less than was? It was math test. So you got to go second math, then find the less than symbol, like that, and then put in the 2, close parentheses. So basically you just got to put it in like that. You got to know where all the symbols are. And what that'll do is it'll graph the line, but it'll only graph it less than 2. Okay, is everybody with me there? Okay. Now go to y2 and just do the same thing. Put the second one in. So now you'll go parentheses x minus 2, then division symbol, then x, and now go to second math until you find the greater than or equal to symbol. So there it is, number 4. Okay, then put in the 2, close parentheses. Okay, so that's what you do. You can do these on a calculator. And I would recommend, like when we do a test, on our first test, we'll talk about that a little bit today, and Thursday will be next Thursday is when I'm going to do that. Well, you'll be able to use your calculator on the test and everything, so it's beneficial to know how to do this on the calculator, right? Okay, but it's also beneficial to know how to do this by hand so that you understand that. Now, just do this. Press Zoom 6. You've seen me do that all semester. That just puts you in a standard window. So it looks the same, doesn't it? The only thing it didn't show is it didn't show the open bubble and the solid bubble, so you've got to know the difference between those two. Do you guys understand why this is open and that's solid? Okay, that's open because that doesn't have an equal to bar method. That's solid because when x is equal to 2, you're on that graph. That's the difference, okay? So that's what you want to be sure you pay attention to. Okay, does everybody follow what I did okay on that? Okay, now if you want to write down, you know, how you do that, just write a note to yourself. You can. You got to put a division symbol in when you do that. And you got to make sure you have parentheses around these things or it won't do it right. So you can write down any note you need to about where that's on the calculator. Okay, all right, let's see. We're going to do one other one. I'll let you try probably to do one of these in just a minute. So that'll be the first example. Okay. So we're going to go ahead and do on example 8, we're going to do this piecewise function to start with, okay? So tell me what kind of numbers I can use on that top graph. 3 and what? 2, below, and so forth like that. So use 3. Is that going to be solid or open? Solid. Put an indicator, a note to yourself. Now just start picking numbers less than 3. 2, 1, 0, 1. Good enough, okay? Just use enough so that you know what this graph looks like. So then what you do is you're going to plug in and you're going to calculate. So we're going to do 3 squared minus 3. See, that's 9 minus 3, so that gives you 6. Okay, plug the 2 in. You're going to have 2 to the second minus 3. That's 4 minus 3, so that's 1. You can do this in your head if you want to. I don't care. Then we'd have 1 squared minus 3 is 1 minus 3, so that's negative 2. And then 0 squared minus 3 is negative 3. And then 1 squared minus 3 is 1 minus 3, so that's negative 2. Okay? So I'm just squaring x and subtracting 3. And you can do that in your head. All right? So go ahead and plot your points now. So we're going to have the point 3, 6 with a solid dot. 2, 1, so you'll go over 2, up 1. 1, negative 2, 0, negative 3, and this should have been a negative 1 right there. I didn't write that down right. You should go down to negative 1. It's still the same thing, though. So you would have negative 1, negative 2 like that, okay? And then this is not a line. This is a parabola, so it goes like that, and then you can just go on forever kind of like that, all right? So that's it. Now, does everybody understand why this graph doesn't continue to go this way? What's the reason? Because if you're less than 3, then there's your graph. Okay. Is everybody with me okay? So I'm trying to get you to understand when you do graphing, it's mostly arithmetic and it's plotting points. That's what you're doing. Okay, if you can do the arithmetic right, plot points right, you should be able to get it fine. Okay, now the next piece is this. Okay, the kind of numbers you're going to use for x is you're going to start with 3. Is that opened or closed? Open. Then you pick numbers bigger than 3. And you don't even have to pick all these, you just because you got to know what this looks like. Well, there's nothing to plug in. Y is always 6, so that's called a constant function. Okay, so what we're going to do is we're going to plot these points then. Okay, so let's see. When we do this, we'll go over 3 up 6. When you go over 3 up 6, that connects with that, doesn't it? Since they connect, it's not an open bubble. Those things connect it. So you notice like on this table and that they're the same point, so they connect. Then the rest of it just graph, like you got 4, 6, 5, 6, so it goes like that. So that's what your piecewise function looks like. All right, tell me if you understand. Piecewise functions are, as long as I've been teaching, which is almost 30 years, students a lot of times don't do them well unless they take the time to crunch out those tables of values. That's what I recommend you do. Do that, and as long as you do your arithmetic correct and choose right points, you'll be fine. Okay? So on the calculator, let's go ahead and just put this one in the calculator, just for a little bit more practice so you can clear off what we have. And go ahead and just try to do that on your calculator and see if you've caught on to what I do. So you do left parenthesis, x squared minus 3. And always make sure that that's enclosed in parentheses. Always do the division symbol. And then do left parenthesis, x less than or equal to 3. So we go x, go to your test command and find less than or equal to. Okay, and then that would be less than or equal to 3. Okay, close parentheses. Okay, and then the second one, you're going to go, you got to put a, you can probably leave the parenthesis off the 6 because it's only one number. And then in parentheses, put in the x, and then greater than 3 like that. And then you can try to graph it and see if it's the same thing we just did. Okay? All right, so I'm going to go ahead and graph. And let's see if it indeed does what we thought. Okay, look at that. Now notice on your graph, on my calculator, it looks like there's a break in there, but there isn't. It's just the way the calculator is calculating it. So this is an accurate graph. The calculator doesn't always do these things perfectly. That's why you got to know how to do this by hand also. Okay, you guys good with what I'm doing? Okay. All right, now let's try to do this on this next page. One thing I wanted to show you is I said sometimes the pieces join. Okay, here's how you can tell, is you can basically just tell that you have the same point. Okay, right there. So notice that you had 3, 6 and you had 3, 6. If those first initial points are the same, then they're going to join. If they're different, then there's going to be a gap. Okay, that's the idea. Okay. Okay, so let's see. I'm going to give you a chance to do one problem. So go ahead and see if you can put number 1 together. Okay, and I'll walk around and see if you know what I'm doing or not. Arithmetic issues. I'm going to go ahead and get what you need up here, and you can kind of check and make sure your tables are okay. So the first table, I'm going to start with 0, and it's going to be solid, and then choose numbers that are less than 0. And it's up to you what they are. I'm just going to use -1, -2, -3, -4. Okay? All right, so when I do this, I'm doing like absolute value of 0 plus 2, that's 2. Absolute value of -1 plus 2 is 3. I think, did everybody get that okay? I corrected some people with that. You got to do absolute value first before you add to 2. So actually, if you went through and used these points, that's what you should have ended up with. You know, if you used -1, -2, -3, 4, that's what you'd have. So if I plot these points, I would have 0, 2 solid, -1, 3, -2, 4, and so forth. Okay, so that would be the way your first piece looks like, is like that. Looks like a line like that. Okay, and then the second piece, we're going to start with 0, but it's going to be open. Now pick numbers bigger than 0 since it says x greater than 0. Yeah, go ahead.
I didn't start with 0. I started with 2. 2? Is that...
That's fine. You're going to get the same thing I had, because on your paper you had -2, 4. Then you also had -4, 6, right?
Oh,
and that's
sorry,
good enough.
I'm talking about the second set of...
Oh, this second graph?
Yeah.
What?
It has to be greater than 0.
Yes, but you want to start at 0 because that's where it comes to an end. But you're going to represent that with an open bubble. You go ahead and start there. That's important. Now I'm going to pick numbers bigger, like 1, 2, 3, 4, and so forth like that. Okay? So I just do like 0 squared minus 1, that's -1. 1 squared minus 1 is 0. 2 squared minus 1 is 3. 3 squared minus 1 is 8. That's good enough. I'm never going to run out of room after that. Okay? So if I plot these points, I have 0, -1 with a bubble. 1, 0, 2, 3, and what else I have? 3, 8, like that. That's good enough. Okay, that's what your graph should look like. Okay, how many people got that? Okay, awesome. Okay, you guys did good. A lot of times test students just don't do this good because they don't take the time to do the table. Yeah.
How do you put absolute value?
That's a good question. I'll go ahead and show you guys how to do that because I forgot to show you that a minute ago. So if you want to try this on your calculator, you'd go like this. The ABS, you probably have to make a note to yourself. You go math. You have to press your math button. And then you got to get it over to the second column, which says number. And then it's that ABS. ABS like that. Okay, that's where it is. So write a note of that if you need to. So you would put this problem in like this. You would have to go parentheses. You would go math, number, ABS, like that. And then that symbol will come up. Then you put the X in. You have to get out of that absolute value carefully and make sure that +2 is outside like that. So that's how you put that in. Then you would say divide by, and then X, test, and then that's what, less than or equal to 0 like that. So that's how you put that in. Okay? And then for the second one, you would go parentheses x squared minus 1, then close parentheses, and then put the condition in, which is x greater than 0. Okay, so it's just, you want to just kind of make a note of where all these buttons are, and if you do that, you'll be fine. Okay, now if I graph that, it should be the same thing we just did. Okay. Okay, so it sounds like we did okay. I didn't see too many problems on that, so that's good. Any questions about that? Okay, the next thing I want to look at is a piecewise function where you have 3 pieces. Then we'll finish up with some just kind of general transformations on here. Okay, so on this one, we're going to do 3 pieces. So we're going to do this one first of all. So when we do this table, you're going to start with -2. Is that going to be a closed or solid bubble? I just said a stupid question. Closed or solid? How about open or solid? Open. Okay. All right, it's open. All right. Now, you're going to choose numbers that are less than -2. And you don't have to choose all of them, okay? Because what's going to happen is the y value is -8 anyway. That's what we call a constant function. Constant functions are always horizontal. They go like that, okay? So I'm going to go ahead and just plot those points. So we have -2, -8 with an open bubble. Hold on. I'm doing this, so I'm not even paying attention. Class, give me a number smaller than -2. -3, -4, okay? All right, I'm not paying attention when I'm doing. So it'll go like this. So that's what your first piece looks like, is like that, okay? All right, now we'll go ahead and go to the middle piece. Now, what kind of numbers are you going to use on this? What does that mean? -2 less than or equal to x less than 2. Everything in between, good. So you will use -2. And since that's got an equal to on the inequality, that's going to be solid. Then you'll just start using numbers between -2 and 2. So I'm going to go -1, 0, 1, 2. And then the 2 has a less than, so it's open. Okay, so it's closed to begin with, open to end. Has everybody got that? That's the language of less than or equal to, okay, versus not. All right, now just cube these numbers. So you do negative 2 to the third, that's negative 8. If you do negative 1 to the third, that's negative 1. 0 to the third is 0. 1 to the third is 1. 2 to the third is 8. You can use a calculator if you have to, but most of those you're just going to do in your head. Okay. Now you want to plot these points. So negative 2, negative 8 is the same point. So what does that do to that open bubble? It closes it, and they have come together. Okay, see these 2 points right here came together, so that means they have these two curves are going to connect. Then we can do negative 1, 0, 0, 1, 1, and then 2, 8 with the open bubble like that. So then you just connect this. Like that. So that's the piece that's in the middle like that. That's a cubic function. Okay. And then the last thing we're going to do is this one. So we'll just use like, we'll start with 2. It's got a greater than or equal, so it's solid. Then we'll just use a couple of things bigger than 2, like 2, 3, 4. Okay. Do the arithmetic in your head. If you do 2 minus 1, that's 1. 3 minus 1 is 2. 4 minus 1 is going to be 3, and then plot your points. So we'd have 2, 1. So over 2, 1, that's solid. Over 3 up 2. Over 4 up 3. And then like that. Okay? All right. Now remember, you have pieces on this, so those lines don't go on forever. They have a boundary to them. 3 tables of values. That's the safe way to do it. Tell me if you understand. It looked like you did the last problem. I could tell. I think we were doing fine on that. The only difference with this one is just got one more piece. All right, any questions? Okay, all right. Okay, now let's see. We're going to finish up with a transformation, just kind of work on this a little bit in general. And what I'm doing next is one of the best ways to test students over this is like on the next page. You know, because you can't really use your calculator on what I'm going to do on the next page. You have to prove to me that you know what transformations are. So here's what we're basically going to do on this problem right here. The first thing is you want to know what these 2 numbers right here do. Okay, let's see if we've got this down. I don't know. Can you tell me what x minus 1 does if it's inside of the function? Right 1. Okay, good. So let's write that down. The first thing we're going to do is we're going to go to the right 1. Okay. Can you tell me what plus 1 does if you're outside the function? Up 1. Okay, you got to get that stuff down. Inside is left, right. Outside's up or down. And the left, right's always backwards of what you think. If it's minus, you go right. Okay. So what we're going to do is we're going to take this generic graph. These are the points, okay? Like the first point is negative 3, 1. This point here is negative 1, negative 3. This is 2, negative 3, and so forth. So I just wrote down those points. That's good enough. So what we're going to do is we're going to do right 1, and then we're going to do up 1. Now we're just going to keep track of this in a table, okay? So if I go right 1, what do I need to do with this? Does x change or does y change? X changes. What happens to those x values? They just get bigger by 1, right? So in your head, make all of those x values bigger 1, but don't change y. Okay, we're not ready to do that yet. So this next step, just leave the y's alone. And then just move these up. Okay, negative 3 plus 1 is negative 2. Negative 1 plus 1 is 0. 2 plus 1 is 3. 3 plus 1 is 4. So all of those x values just went up 1. I added 1 to them. Okay, what am I going to do with the up 1? Do I change x or change y? Change y, good. So in your head, you want to change all of these y values up 1 while you leave x alone. So x is, we got x where it needs to be. Okay, so 1 plus 1 would be 2. Negative 3 plus 1 is negative 2. Negative 3 plus 1 is negative 2, and then 4 plus 1 is 5. Okay, so if you do it this way, you can keep track of your points Good, okay. This problem's easy enough that you could probably do in your head. Now what you want to do is just take these points and plot them, and then we got what our graph looks like. So I'm going to plot -2, 2 is my first point. 0, -2 is my second point. 3, -2 is my third. And then 4, 5 is my fourth one. And just connect them. Just connect those into line segments like that. Now this one's easy to see. Can you guys see that the blue graph, all I did was moved every point right 1, up 1. So you can do that problem in your head. That's easy enough to just move those points, then you got what your new graph looks like. So that's the transformation of that function. That's how you transform those points, okay? All right, everybody got that okay, you think? Okay. All right, let's do one more, then I'll let you maybe try one of these, and then I'm going to finish up with business application before we take a break. I want to finish this section before we do our break. Okay, so this one, let's see if we kind of know what happens on this one. I'm taking the same thing. Do you know what the -1/2 does? It's outside the function, and it's multiply, right? So what does it do? Does it multiply y by -1/2 or x? That's the key. Y. Anytime you're outside the function, it's affecting y. So what I want you to write on your table is multiply y by -1/2. That's how you got to start. You got to multiply before you add. What does the +2 do? Up 2, good. Okay, in order, so we got to do that, all right? So you got to be able to identify the transformations and know the order you do them in. Left, right first, multiply y second, add, subtract. You got to get that order down, okay? So what we're going to do first of all is in our first step, don't change the x value at all. Leave that x value alone. And in your head, if you can do this in your head, just multiply all of these y values that I'm highlighting by -1/2. Okay? So let's say, I'll do this kind of the side. 1 times -1/2 is -1/2. Okay? The next one is -3 times -1/2. Well, you multiply fractions straight across, so that's 3/2. 3/2 is 1.5. You can use a decimal if you want to. Okay? The next one's the same thing, so that's also 1.5 because it was the same y value. Then take the 4. 4 times -1/2 is -4/2, so what is that? -2. Okay, so I'm taking half of the y value. You can use decimals if you want to. Okay, now we're going to move these up 3, or no, up 2, so the x values are where they need to be now. Okay, we're not going to change the x values on this problem, actually. And now you want to just take all of these y values in your head, if you can, move them all up 2. Okay, so remember, this first one is -0.5 plus 2, so that's going to be 1.5. Okay, 1.5 up 2 will be 3.5, so you'll get that. And then -2 plus 2 is 0. So what I'm doing is making all those y values increase by 2. All right, plot your points, and let's see what we get. Okay, so it looks like we have -3, 1.5, so that's there. -1, 1.5. No, -1, 3.5. Oops. So second point's -1, 3.5. So it's up there. And then over 2 up 3.5, and then 3, 0. Okay, so if you connect those points, it goes like that. So, do you see that it flipped? Okay, what made that thing flip? The negative, that's the 1/2. That caused everything to flip. Okay, can you tell that everything's up 2? It's kind of hard, because it did flip, so it's kind of hard to tell that on this one. All right. But can you tell that it kind of shrunk a little bit? It's not quite the same shape, so it's off a little bit like that. Okay? All right? So this is kind of a safe way to do this, is if you know how to do the arithmetic, you're going to be okay. All right? Okay, so I'm going to have you try one problem. This one's a circle. It's still the same thing. What I want you to do is see if you can figure out how to get your table filled out, and go ahead and do that. So you got to figure out what the x plus 3 does, and you got to figure out what the -2 does. Okay, if you know what those are doing, then you'll be in good shape, as long as you can do your arithmetic okay. Yep.
So this is y -2 times the entire function of x plus 2?
Now, the -2, you're going to multiply all of the y values by that. Anytime you have a number in front of the function multiplied, you multiply y. What's the x plus 3 do on this problem? Left 3. Which do you do first, left 3 or the multiply y by -2? Because it does matter. What did I say? Left, right. You work in parentheses first. That's order of operations. You're going to do left 3, then you're going to multiply y by -2. You got to do it in that order, because if you don't, you're going to be wrong. Yeah. And you'll have a circle. It'll kind of change the way it looks a little bit.
Even though it's plus 3?
Yeah. See, the left, right is like backwards of what's logical to students a lot of times. Plus is that way, minus is that way. But if it's up, down, plus is that way up, down. Like we went over that class. I mean, you have to crunch out the number.
I think I was not here.
Okay, you may not have got that. Okay, yeah. Because that, see, that's inside the function. See, that's outside of f of x. So that's what causes it to go up too. Anytime you're outside adding or subtracting, it's up or down. If you're inside the function, adding or subtracting, it's left, right. Got to get that down. So you have a kind of a semicircle that's been stretched and reflected, and that looks pretty good. That's kind of just eyeballing it. That looks like they're on the right track. Yeah, left, right. Yeah, left, right. Do that first. And just plot your points. Once you got your 3 points, plot them and see what you get. You did left 3, and then multiply y by -2. Okay. Go ahead and plot your 3 points. So you should have got like a semicircle upside down and stretched. That looks right. Yeah. You get something you tend to do okay. So. Okay. Okay, that one's that's a little tricky. Okay. That's already okay. Okay. You got the left 3 taken care of?
Yeah. You get it.
Yeah, just go ahead and put those same y values. And then the x's are going to stay the same. Okay, and then the next step, well, you got the x's, and the y's, you just multiply them all. So you'll end up doing -2 times 0, -2 times 2, -2 times 2. Then you got it. So if you get a semicircle upside down and stretched a little bit, okay, I think that looks right to me. Okay. Should be getting a semicircle stretched and reflected. Okay, so yeah, left 3, let's just make sure you got everything. So when you do left 3, you would have -5, 0, -3, 2, and then -1, 0. So again, all of those x values just get smaller by 3. Okay. Then what you're going to do is going to multiply y by -2. So these x values stay the same. The x values you should have plotted were -5, -3, and -1. And then just in your head, multiply those 3 numbers that I highlighted by -2. So 0 times -2 is still 0. 2 times -2 is -4. 0 times -2 is 0. How many people got those 3 points? Outstanding. So it's arithmetic, okay? So now, if you go through and plot this, you'd have -5, 0, -3, -4, -1, 0, and it's still a circle. It's a semicircle. It kind of looks like that, okay? So it kind of stretched and reflected. Everything got stretched because of the 2. Yep.
This might sound stupid. So I basically just got instead of a circle, I have to remind me as like a jagged V, like on a test with that.
Oh, it's got to be a circle because it started a circle. So and the only way you could really see that is to get more and more points. But if the general shape's always going to stay the same, so it isn't going to transform into a V or anything. It's still a circle that's stretched. Okay, I'd take off a point or something. Okay, all right. Why don't we go ahead and do a break now? Let's come back at 1 o'clock, and then we'll just do this last page when you get back. 2%. Okay, so I look at this first thing like this. When we write this, let's just say t of x. And when you do a piecewise function, usually you write it like this. You usually put a kind of a brace like that. Okay? How do you do 2% of a number, by the way? Like if I wanted you to do 2% of 10, how do you do that? What do you do on your calculator? You do 0.02 times 10, right? So you got to know how to do percentages, okay? You move the decimal to the left 2 and multiply. So the first thing we're going to do is x is going to be whatever your income is, okay? That's your income. So what you would say is you would say 0.02x. Now, you got to give the condition. Now, you got to be real careful about that. Okay, we're going to be between 0 and 25,000. Okay, but you got to put the right symbol there. What should I put here? Less than or equal to? It said over 0. So what would that tell you? Less than, not equal to. Okay, it doesn't say if you make no money that you're going to be taxed. So it goes like that. Now it says not over 25,000. Would this be less than, or would it be less than or equal to? What do you think? Not over 25,000. When I read that, that tells me 25,000 is okay. When you get over 25,000, you're going to go to the next tax bracket. Okay, that's the first piece. You're going to take 2% of your income between 0 and 25,000. Tell me if that makes sense. Okay, now let's look at the middle piece. So the middle piece, okay, what it's going to say is, okay, this is when you start making over 25,000, but you don't make over 100,000. So I would look at this like this. Okay, you're over 25,000. So that means that's less than. But you're not over 100,000. So that means if you're equal to 100,000, then that's your tax bracket. Okay, so it's like that. It's between 25,000 and 100,000. Okay, now let's look at what this says. This you got to be careful about. You're going to do $500. Regardless of how much you make, we're going to charge you $500 for your taxes. Then we're going to do 4% of the amount you make over 25,000. Well, how do you take 4% of a number? You do 0.04, right? Okay. How are you going to figure out the excess over 25,000? Because what's going to happen is, say for instance you made $26,000. If you made $26,000, how much are you going to get charged on 4%? Are you going to get 4% of 26,000? Or are you going to get the difference between 26 and 25?
Subtract.
There you go. You're going to subtract. So you're going to take your income minus 25,000. Okay, just think about what that does. I mean, if you made $50,000, you would find the difference from 50,000 and 25,000 and take 4% of it, then tack on 500. Does that make sense? Tell me. I don't know. Makes sense to me. That's what excess means. So you're going beyond that 2,500. Okay.
Makes sense to George Washington.
What's that? Yeah, I'm sure it does. All right, let's look at the next one then. Okay, so this is when you're over 100,000. So you would just say bigger than 100,000. Okay, and that would have to be greater than. Now this one, it's almost the same thing. You would say 3,500 plus 6% of excess over 100,000. That's almost the same thing. You have a flat tax rate of 3,500, and then it's 6% of X minus 100,000. So you find out how far above 100,000 you are, and then that's 6% plus the 3,500. Okay, does that make sense? Okay, all right. So what we want to do, we're going to do this on our graphing calculator. So when we do the graph, These are pretty big numbers, so you want to know how to do this on a calculator. Okay. So let's see. With this one, we're just going to get kind of and we're going to do kind of a rough graph. So let's see. I'll show you what you need to do on this now. Now, there's a couple of new things I need to teach you on this, and you're going to probably need to write this down somewhere on the calculator. What I'm going to do is, let me have you go ahead and write down what you're going to put in your calculator so you'll have this in your notes. Okay, the first thing you're going to do in Y1 is you're just going to put in parentheses 0.02x, then your division symbol. Now, you got to put this in a little bit different way. Okay, you have to put this in like this. You have to say x is greater than 0, and there's an and thing that you have on your TI, and I'll explain this in just a minute. I want you to get written down what you do, though, first of all. Then you say and x is less than or equal to 25,000. Okay, let me explain why you have to do that. Okay, first of all, x is bigger than 0. Okay, your income is bigger than 0, but at the same time, it's smaller than 25,000. Does that make sense to you? If your income's between 0 and 25,000, you're bigger than 0 and at the same time less than 25,000. Is that logical? Well, you gotta have that and. I'll show you where that and button on your calculator is here in just a minute. Okay, Y2. What you put in Y2 is you put this in. You put parentheses 500 plus 0.04 times x minus 25,000. Close parentheses, and you got to double up on those parentheses because the whole thing's got to be in parentheses, then division, and then this is going to go like this. Okay, you're going to do the same thing. You're going to say x is greater than 25,000, and at the same time, x is less than or equal to 100,000 like that. Okay, so that's how that would go. And then the last one's a little easier. What you do in Y3 is you go parentheses 3,500 plus 0.06, x minus 100,000, then double up on the parenthesis, and then division symbol, x greater than 100,000. Okay, so I want to get that in, and I'll show you where that is, okay? Now, like in business and so forth, you do a lot of stuff with computers and spreadsheets and stuff like that. So if you were going to make a spreadsheet out of this or something, which you would do in business classes and stuff, well, you'd have to know the mathematics behind that. You would have to figure that stuff out, okay? So what I'm going to go ahead and do is, let's go ahead and see if we can put this in the calculator, and it'll go like this, okay? So Y1, you're going to put left parenthesis, then 0.02x, like that. Okay, always make sure your function is in parentheses. Then do division symbol, and then left parenthesis. Now and will show up. Let me show you where everything is. If you go second math, all this stuff is under the test menu, so if you go second math, you'll see, I've already shown you where that is. If you go over to logic, then you have and. So you're going to kind of use the test menu and use test and logic. That's where you're going to find everything, okay? So it goes like this. We would say x test greater than 0, like that. Then you'd have to go back to your test, to logic, and get and to come out. So you just got to know where everything is. Then you would say x, back to test, and then it would be less than or equal to 25,000 like that. So if you can find all your buttons on here, you'll be fine. So that's how you do that. Okay, just try to put it in exactly the way I've written down. Okay, go to Y2. It go like this. We'd say parentheses 500, 500 plus 0.04, parentheses x minus 25,000. Then you got to double up on the parentheses because the whole thing's in a parenthesis. Then you say divide by parenthesis x test, let's see, greater than 25,000. Okay, then you got to get the and to come out. So and, remember, you go second test logic, get and to come out, and then go x less than or equal to, I know I'm doing this kind of fast, but as long as you got it written down, you can spend a little bit of time outside of class and know where everything is. Okay, so that get, whoops, I got to get back here. Now I'm getting myself messed up. Let's see, got 25,000 and then I need to do x less than or equal to, and what was that, 100,000? I'm almost got it. Okay, so got that. All right. And then the last piece, we'll do 3,500 plus 0.06, and then parentheses x minus 100,000. Double up on the parentheses. I hope I got all this stuff right. And divide by parentheses, and then put in x and greater than 100,000. God, I hope I put this in right. Okay, so I got that. All right. Okay. So as long as you know where that test, all you got to do is know where everything is. Okay, and just type it in. If you've got that written down, you're fine. If you don't get it put in class, that's fine. Now what we're going to do is we're going to do the window. Okay. So the window. Well, we're talking about bigger than 100,000, right? So for x, we're going to start with 0. That's your income. And let's go up to like maybe 150,000. So let's do our window kind of like 150,000, and then maybe we can scale this by 25,000. So that would be, to me, a pretty good way to scale your x-axis, is just go by 25,000, okay? Now, you're getting taxes on this, so let's go, for y minimum, let's go 0. I'm just going to take a guess on this. If you're making over $100,000 by this, I don't know. Maybe it's going to be 30, 40,000. I'm just going to take a wild guess. Let's just say 30,000. I mean, we can adjust it if we need to. So I'm just going to start us with this window right there. So we can go 0 to 150,000 and then 0 to 3,000 on y. Okay, like that. Now, usually I can slide this window over on here. There we go. So if you need to, if you're putting this in your calculator, do that. Now I'm going to graph and I'll see what I get. Okay, well, okay, that's probably not the best thing. Probably the 30,000 is too big. I would say, let's go to 10,000 there. Okay, and then let's see what this looks like. So I'm going to change the y to 10,000. And I'm just going to have us just really roughly draw this graph. And then we can scale by 1,000 like that. So that's probably 10,000 scaled by 1,000. Now this will just look better. And then this is what we're going to sketch on our paper. Okay, let's see if this makes sense to us. Okay, so this is 25,000. Your taxes are getting bigger. Now what's happening? Taxes are getting bigger at a bigger rate, right? And then once you're past 100,000, it's going like that. Does that make sense? As that graph is showing what your taxes are at those particular points in time. So here's what we're going to do on this, and I'll show you how you can use your calculator to make a good graph on this, where you can get points pretty easily with your trace. So just kind of watch what I'm doing here. On your graph, let's go ahead and get everything put up. We're just going to maybe make every, you can put 25K for 25,000. And then we can go, just kind of break it up however you want to, 50, 75, 100,000, and let's see, that would be 125, and then 150 like that, okay? And you want to label that as your income. So you would want to label this as income in dollars, okay? So it's like that. Okay, and let's see, our y-axis, we're going to go to we said 10,000. So let's just kind of go, every 2 would be 1,000. So that would be 1K, 2K, 3K, 4, 5, 6, 7, 8, 9, 10. You can scale it kind of however you want to. That's just kind of logical to me. So that'll go all the way up to 10K like that. Now what you would write is this would be your taxes in dollars. So you always got to label what everything is. Okay. Now, hey, we're going to get an accurate graph. I don't want you to just throw something on there. What you do is you use your trace. So we're going to go like this. Trace at 0. Okay. Now we know that if you have no money, you pay no taxes. Okay, so we'd have kind of like a bubble there at 0. Okay, then go to 25,000. So if you trace at 25,000, that's where the end of this tax bracket came to an end. I like that. Wow, $25,000, you only pay 500 taxes? I wonder how accurate this is. So anyway, let's go 25,000 and up 500, okay, which would be here. And then just sketch that in like that, okay? All right. Then let's go to the end of this tax bracket was what? 100,000. So now I'm going to trace at 100,000. Okay, like that. And that means we're undefined, okay, but we can go up a little bit further. So if we go like this, we got to go to the third graph. So if you go a little bit higher than that, you can go like this. You can just go trace. I'm going to put 100,000 in again, but you have to be on the black graph. So I have to toggle usually up and down with these things to get this on that right graph. And for some reason it isn't working for me. Let's do this. You can do this actually. You can go like 100,000 and 1. And then that should put you on, why is it not going to the black graph? Oh, there it goes. I just did something. There we go. Okay. So now I'm on the black graph. So if I go 100,000, then that'll give me about, it still didn't work. Try one more thing. There we go, about 3,500, okay? So what I'm going to have on this is if I go here, if I go all the way up to 100,000, then I'm up at about 3,500. Then you can connect that like that. And then we can just go to the end of the graph. Now you can always just trace. So like right now, if I go through and trace, just keep pressing my left arrow key, you can just get an estimation on there, okay? So and I can also like trace at 150,000 and get it that way, okay? All right, so I'm going to do is just kind of, you have to toggle up and down. When I do the up down, it toggles between the graphs. So if I'm on the black graph, I got to get that on there before I trace. Now if I type trace at 150, I think it should work as long as I'm on the black graph. Okay, and it messed up again. Okay. Let me try that one more time. Okay, there we go. 6,500. There's a good point right there. I've got 150,000 and I'm about 6,500. So that's 3, 4, 5, 6. Just kind of estimate where that is. Okay. So anyway, that would be kind of how your piecewise function goes. Okay. Now the key thing on that is that you got to know how to do that. I wouldn't want you to do this problem any other way except just do that graph on your calculator. So that's how you would put everything in. Okay. All right. You guys got that graph? Okay. Just kind of a rough graph. Okay, so these are your 3 pieces right there. Okay, one last thing to finish up. It says find the tax at 55,000. Okay, so here's what you do. Look at the piecewise function. When you're at 50,000, do you use which piece do you use? The first, the middle, or the last? Okay, you're in the middle tax bracket, so you're going to do 500 plus 0.04 times x minus 2,500. So let's write that down. It would be 500 plus, and it was, what was it, 0.04 times x minus 25,000. Okay, and then what you're going to do is you're going to plug in the 55,000, and we'll just do this on the calculator. So you'll do 500 plus 0.04, 55,000, minus 25,000 like that. Okay, so that would be 500 plus 0.04. And let's see, the difference between that is you would be 30,000, and then just do that on your calculator. Okay, all right. So I'm going to do this on my calculator. So I'm going to get the fixed 500 plus 0.04 times 30,000. Okay, and that's going to be a tax of $1,700 for that income. That's what that is. Okay, all right. And then the last one is 100,000. So if it's 100,000, I think on that one you need to look at the piecewise function we wrote, and that was the last piece. Okay, I think that one was, now that's still the middle piece, okay, because you still do the same thing. If you are 100,000, you still do the middle piece, okay, because that said less than or equal to 100,000. So you just do the same thing on this. You would do 500 plus 0.04 times 100,000 minus 25,000. So that would be 500 plus 0.04 times 75,000. And then you can do that on the calculator. Okay, so let's see what that is. Okay, so that's $3,500 for that income. There's no way that's accurate. Okay, I took that problem out of the book, so I said it was Louisiana. I don't believe that for a minute. Okay, all right. So I guess the key thing to me is the graphing calculator is kind of complicated on that thing a little bit. But does everybody understand the piecewise, how I built that? Is that sensible? I don't know. Okay, okay. Taxes are an example of a piecewise function because we have tax brackets. If you want to make taxes simple, you just do a flat tax on everybody. Some people say we should. Okay, so we're going to start the 2.3, and we need to go ahead and get a lot done on that, just kind of the basics.